Welcome to your go-to podcast for the pool and spa industry. My name is Tyler Rasmussen.
And my name is Greg Villafania. And this is the Pool Chasers Podcast. All right, so the next thing we're going to jump into is our friend PH. We're going to talk about that a little bit.
Yeah, absolutely. And it is, you pronounced it correctly. Very good. Bravo. Polite golf applause.
Well, I usually call it...
Or... Yeah. I, in fact, I've gotten calls, Taylor, before. Do you have a PA test? Excuse me. A PA test, yeah. I got your PA test right here. You know,
yeah, a customer had to tell me how to say it right.
Oh, Lord. But pH actually does stand for something, the power of hydrogen. And it's the number of hydrogen ions associated with a body of water. And that's how you measure pH. It's a logarithmic measurement. So it's a little bit different than all the other tests that you do. You just don't know it. Because the most common way to test for pH is with a color matching test. You get a sample of water, you add an indicator to it, it turns a certain color, usually somewhere between yellow and a deep red, and then that's your pH value. And with pH, it's everything has a pH. That's the neat. Absolutely everything has a pH. We have a pH. I mean, what's the first thing that they do if they take your blood if you go to the hospital for some reason, God forbid? You know, they do blood tests, and one of those blood tests is your pH. Because if your pH is too high or too low is called acidosis. You know, that can cause a lot of problems, right? So everything, and that includes treatment products, chlorine, sanitizers, bromine, algicides, you know, bicarb, soda. Everything we add to the water has a pH that can overall affect it. So measuring pH is critical to make sure, one, that you're within the right range of pH. And so the ideal range for pH is 7.4 to 7.6. Okay. And that's a comfort issue. The concept is if you open your eyes underneath water, okay, the pH of the tears in your eyes is 7.5. And if your pH is 7.5, you open your eyes, they're not irritated. Now, this is, of course, assuming you've taken your glasses off and you pop your contacts out, but it's a comfort issue. Higher pHs can cause irritation. Lower pHs can cause irritation. We all know that, at least physically on your body. Now, when we measure pH for pools and spas, we're using a product called Phenol Red. And Phenol Red measures pH in the range of 6.8 to 8.4. There are other pH indicators that measure different ranges. There are even some long-range pH indicators, some that go a little bit lower, a little bit higher. Back in the early days, before Phenol Red was more popular, they used to use something called chlorophenol red to measure pH in pool and spa water that measures from 7 to 9.4. But Phenol Red kind of covers the bases a little bit better, 6.8 to 8.4. And doing a pH test, again, you add your indicator, you match a color, pretty simple. Some people use a pH meter, which is good too, which is fine. Again, with meters, keeping them clean and calibrated, very, very important, very critical. Sometimes there are online systems, depending upon what you have, that will automatically show the pH, which is fine. But when you're talking pH testing, one of the weirdest, not weirdest, but one of the most common questions I get is, I did my pH test, but my water's purple instead of the yellow to red. What on earth happened? And I said, yeah, it's a pretty great Kool-Aid color kind of purple, isn't it? And she said, yeah. The reason is high chlorine or bromine levels can actually change the physical nature of Phenol Red and essentially convert it into another indicator that comes out as purple. So if you get that purple color, two little bells go off. One is that your sanitizer level is really, really high. And two, you need to measure your pH. You need to get the right answer. How do you do it? This one's really, really easy. Correction for this interference. You get a new sample of water, okay? You add 1 drop of reagent number 7, which is thiosulfate in a Taylor kit. 1 drop only. Mix it around, then you add your indicator. You're good to go. You'll get the right pH reading. And now you're going, well, how does that work? Well, what happens is that 1 drop in that 44 ml sample of water wipes away any kind of halogen presence, any chlorine or bromine in there, okay? And which allows the indicator to react properly. The problem is that, again, more is not a good thing. People will add more drops thinking more is better, and it's not of number 7.
So is that acting as a kind of like a buffer?
It's acting exactly like a buffer because the pH of number 7 is 9.6. And 1 drop in that 44 ml sample is fine. It's great. Good to go. 2 drops or more actually will change the physical pH of your sample. So you're going to read a false high answer. Okay, so 1 drop is all you need. In most Phenol Red indicators that most of us test kit manufacturers make, there's already an inhibitor in there that prevents this kind of interference, up to about 15 parts per million. Okay, so if you get a purple reading on a pH test from like a Taylor kit, some of the other ones out there, that usually means your chlorine level or bromine level is greater than 15 parts per million. Okay, this one's really easy to take care of, and you don't see that interference if you're using a meter. A meter.
Well, excuse me?
Got to take two. You don't see that interference if you're using a meter. Okay,
Right.
and because there's no chemical for it to react to.
Why do you want to have pH balanced, and what would cause pH to fluctuate?
Okay, why you want to have pH balance? It's a comfort issue. Okay, like I mentioned before, that range is 7.4 to 7.5 is the most comfortable feeling on your skin when you get into the water. Okay, higher pHs are irritating. It can also cause cloudy water. Lower pH is very irritating. Can also cause acidic water, which we know is a bad thing when you're talking water balance, and cloudiness contributes to scaling. As far as what was the second
The
part?
cause?
Of the cause can be anything. Overuse of treatment product, a recent shock, and you didn't give it enough time for the shock to dissipate out before you took your test. Okay, you should always wait at least one turnover before you retest to make sure you did something right. Always one turnover. And again, a turnover 6 to 8 hours usually before you retest, because you'd actually be reading an incorrect pH because it hasn't mixed through all the way.
Sure.
Yeah.
What about the rain?
What about the rain?
Can rain
Ooh, that's a good one.
change it?
Absolutely. We've heard of acid rain. It happens depending upon your geography, whether it really has an effect. Where I am, and not so much. With acid rain, obviously you're going to have a situation where it's going to pull the rain down, pull the pH of the pool water down. But you would have to have a lot of it over a long period of time, like a hurricane, and that kind of thing. Also, something we're finding out too, with all the fires that are going out in California and the West Coast, the flame retardant chemicals that they're using when they bring the planes over and they douse the fires have a lot of phosphates in there. So now they're or orthophosphates, and they're introducing a lot of this thing into pool water that was never there before. That's changing all the chemistries of the pool water. So, and we just found that out. Well, not just found it out. I found out about it about 6 months ago or so from a service guy out in that area, that he was getting all these weird, funky readings from his pool water, and he didn't know why. And come to find out, the people came by and and doused it in that area. So yeah,
And that's one of those things. It's like, yeah, it doesn't matter. We're putting out fires.
Yeah,
We care
exactly.
less about your swimming pool.
Yeah.
We don't put this fire out, you ain't gonna have a swimming pool.
Right.
yeah. Well, that's what they tell the people out there. If you have to evacuate your home and you have a pool, don't drain the water in the pool because they might need to use it.
Oh, wow.
Because they have had situations in which they've actually had helicopters come in and scoop out pool water from homes and use that to help douse some of the flames.
What?
Yep. And same thing out on the East Coast that's happening now in the Hurricane Florence, is that they're telling people, they're saying, the people say, well, should I drain my pool? That kind of thing. No, don't drain your pool, because if you drain your pool, it could pop out of the ground, number one, and actually having putting in your patio furniture in the pool water is the safest place for it, because that way it's not going to fly around and do any other damage.
Be
That can-
stable.
Nice.
Yeah. So aren't you glad you don't live on the East Coast or the West
Yes.
Coast right now?
Hey, we get monsoons, okay?
Okay.
Yeah, we do get that.
Yeah, right. Okay, sure. I get snow, so there.
Haboobs.
So with pH, that the high sanitizer reading, whether it's chlorine or bromine, is the only really thing that's going to screw up a pH test, quite honestly. Okay, but remember, total alkalinity works hand in hand with pH. So can I lead into that a little bit?
I was just
Or do
going
you
to
wanna
add
ask
one
another
more
about
thing
pH?
for pH. Maybe you could just share with us the most common, things to add to the pool to bring pH up
Sure.
or lower pH.
Sure. The most common product to add to increase pH levels is a product, soda ash, which is sodium carbonate, 100% sodium carbonate. To lower pH, you add acid, whether it's muriatic acid, the liquid, or if it's dry acid, sodium bisulfate. Doesn't matter. It does the same thing. Okay.
And what's good practice for adding those with, leaving the equipment running? Should you size up the pool? How much do you know how much to add?
Yeah. For changing pH values, the Taylor test kit that we've been referring to has something in it called an acid demand test and a base demand test. Now, what these tests do will help you figure out how much of that product to add to make the change. And when I say an acid demand test, what it is you have your pH, your treated pH sample, and it's really high. It's like 7.8, but you want to lower it to 7.4. What do? Well, the water's demanding to be more acidic. So you're doing an acid demand test. You're adding a little bit of sulfuric acid drop by drop, mixing it in between drop until it gets down to the color where you want it to be. Then you take the number of drops it took. Let's say it took 3 drops. You go in the charts in the back of the booklet. You find out how many gallons of water you have, and that will tell you how much acid to add, whether it's dry acid or liquid acid. And the base demand test works the same way, but in the other direction. Okay. In this case, you're adding sodium carbonate a little bit in liquid form. You're adding it drop by drop until the pH goes up to the level where you want it to be, and then you check the charts, and it will tell you how much soda ash to add. Yeah. Acid demand test, base demand test, which are probably the 2 most least done tests in the entire kit ever.
Right, sure.
And I mean, like the pool we saw earlier today, you know, being between 10 and 15,000 gallons, is there kind of safe practice for how much, you know, muriatic acid you would add to a body of water at a time?
Yeah, I generally, that size pool that we were working with earlier, I wouldn't really add more than a quart in it at any one time, making sure the pumps, you know, everything's filtering through and the pumps are filtering through. Only in extreme situations would I recommend more. I mean, if it was a bigger pool, yeah, maybe a gallon or 2 or something like that, but no more than a quart, really.
Because you risk, you know, hurting the surface of the pool.
Yeah, you don't want to damage the surface. Exactly right. Yeah.
Because you'll get discoloration. You know, the pool can start etching over time.
Pitting. Yeah.
Adding tons of stuff over time.
Yeah. Absolutely.
This is kind of off a little bit, but it might have to do with pH. In any given time, if say, because we have a customer's pool that it's a plaster pool, but I mean, it's just etching so bad to where you almost can't even brush it because it just flakes off. Wow. And there's tons of stuff that just goes into suspension. When you have something like that, you know, where a pool is etching, does that, you know, pieces of the plaster that might be etching, does that affect anything in the water chemistry?
No, not really. It would have to be solubilized. In other words, it would have to be mixed with the water so that you no longer see it. In this case, it's just a chunk of something, and it's floating around. It's not going to really affect anything now.
Okay.
Yeah.
Even if it's like a powdery, if it's just powdery.
If it's powdery, it could be anything. Obviously, I mean, you don't obviously want it sitting on the surface for any great length of time. You want to try to either get it out, you know, vacuum it to waste if you can, or correct the chemistry,
Right.
so that it goes back into solution. That's a lot of times an easy quick fix is, you know, change something in water balance to make the water balance, because the reason it's cloudy or misty or whatever you want to call it like that is that the water's out of balance. And etching, that's a perfect example, is that the water's out of balance for some particular reason. It could be any one of it probably not temperature, but it could be high TDS level. It could be weird pH and alkalinity and hardness readings that are just combining, and then you got the little perfect storm of a bad out of balance pool. That's causing it. Yeah.
What kind of damage can you do if you have too high a pH or too low a pH?
Okay. Well, with low pH, it's more of an acidic condition, so you can start eating weight like in impellers and things like that, and pumps can go up and whatnot. If it's a high pH, you're going to see a lot of cloudy water, and the potential for scaling too. It combines with the calcium hardness, and it gets that little rough surface sandpapery kind of feel on the side. That's on the ends, the low and the high end. Okay. Yeah, and the same things for alkalinity too. Will cause the same things. Yeah.
And just like every other chemical too, be safe handling, especially the muriatic acid, because when you're pouring that in, and you know it could always splash back on your hands, your clothes, God forbid your eyes.
That's why we have those pair of jeans that have the bleach marks all over it.
Somehow it's become every pair of my jeans. Where here, I think I got some right here.
Yeah, you do own that.
There you go. There you go.
Put a hole in my jeans.
There you go.
That's how they know. I go to my daughter's school. Like, what do you do?
Guess what?
You a painter?
Yeah, and you know, you guys do this more than I ever do. But anytime you're adding dry acid or liquid acid, you want to get as close to the surface of the water as you possibly can. Okay, if it's dry acid, I like to pre-mix it and then pour it in front of a return line so it disperses out easier. Never put anything in a skimmer. Never put anything in a skimmer.
Just chlorine tubs?
Never put anything in a skimmer. I'm going to throw my phone at you. Now, the only time I would ever recommend telling somebody to put something in a skimmer is if it's a brand new fill and they need to add cyanuric acid. Then I would say go ahead and add the cyanuric acid premixed into a skimmer so that it starts getting through the pump system. Because if you just pour it, it's just going to sit there. Mm-hmm. You want it to work quickly. That's the only thing I would ever put in a skimmer. Now I've seen
DE.
Or DE, right? Now again, another little bit of an exception is these what are they called? The pills that treat metal chelator. Balls. I don't know if you guys seen these. They help control metals. They look like a little tiny solid colored tennis ball, and you put them in the skimmers, and they're supposed to help control metal in the water. And I understand they work pretty good. That would be the only other thing I would say. Put in a skimmer.
Okay.
Yeah. The important thing with pH is make sure you get as close to that ideal range of 7.4 to 7.6 as you possibly can. Okay. Now we all know. Here's the other kicker. At lower pHs, chlorine's more effective.
Yes, every pool guy knows that.
Okay, every pool guy knows that. So if you're shocking a pool, for example, sometimes you lower the pH to like a 7.2 or 7.3, so the chlorine you're adding to shock the pool is more powerful, is more effective.
Yeah, I heard a lot of that, like green pool treatments. You add half gallon of acid along with all the.
Exactly. Yeah. And you're doing that to lower the pH. Mm-hmm. Okay. At higher pHs, chlorine is not as effective. It's still there. But it just doesn't have that bang behind it.
So what I was going to ask is, when you do need to add muriatic acid, to adjust the pH, where's the best place to add it in the pool?
In front of a return line.
Okay.
Yeah.
So it's not. I feel like most of the time people will try to spread it out throughout the whole entire pool.
And that's probably the easy out kind of way to add it. The best thing is like say you have to add a quart of acid for whatever reason. Okay, what do? Well, I'll first of all find out where my return lines are, count them, and just kind of if I have 4 return lines and I want to put a fourth of it in front of one, a fourth, etc., to kind of spread it out. I know some people will walk it around the edge, and that's fine too. But I'd rather see it in front of return line because you get more push out so that it gets throughout all the water.
I think the way you just said is a really good way to do it because I think you'd pay closer attention to how much you're actually adding because when you're walking it around a pool, very easy to dump half a gallon or even more in there. Like, oh shit, what happened? Like you just walked around
in one spot,
40 feet.
That could be a problem.
You know what I mean? So yeah, that's a good place to do it. And I've heard, if it's more maybe like a dive style pool where you have the deep end, maybe do it with like the diving board would be the return on the opposite end would be a good place.
Yeah. That's if you want to get out on the diving board.
You saw me do it earlier, man. I would reach out and I'm not doing
I've seen ridiculousness too many times. I've seen those videos where they fall.
Me too.
How do you suggest adding soda ash to a pool? Pre-mixing it?
I would pre-mix it. Any kind of a dry product, for the most part, I would prefer pre-mixing and pouring it in front of a return line. It's just it's easier to handle that way. And if it's windy, and you're not faced in the right direction, you didn't want a face full of acid or dry acid on you or something like that. But it's usually easier to pre-mix it.
Or when shocking a pool, that's fun.
The shock. Yeah, definitely don't get downwind.
No,
like Nair, just
shave your arms off. What hair?
You said earlier that pH and alkalinity go hand in hand.
Right.
So you want to talk about alkalinity for a little bit?
Yeah, absolutely. And alkalinity, total alkalinity. Controls everything, I guess is the best way to put it. And when I say alkalinity and pH work hand in hand, the same treatment products that you use to adjust pH, you use to adjust alkalinity. So I always tell people that if you're changing, or if you're correcting one, retest the other when you're done, because that's going to change too. So if you're correcting pH, test your alkalinity also, okay, when it's done, because that's going to be off. But with total alkalinity, and the best way to think about total alkalinity is think of it as an umbrella, okay? Total alkalinity is this umbrella. And the umbrella, it protects you, right, from rain, okay? Well, pH is sitting underneath that umbrella, all right? If your umbrella is too big, it's like a crippy beach umbrella, and you have tiny little pH underneath that umbrella, it looks up and it's scared to death because it has this thing looming over it. It doesn't know what to do. There's too much alkalinity. Have you ever heard of the term overbuffered? Okay. That's exactly, or pH lock, pH lock. That's what happens. There's so much alkalinity in there, it's over buffered. No amount of an acidic product or a basic product is going to move that pH. On the other side of things, if you have too tiny of an umbrella and you have pH trying to be protected by it, and the pH is because the umbrella is too small, pH is jumping around all around trying to find its happy spot, and it can't because this umbrella is too small. It's under buffered. Ever heard of the term pH bounce? That's it. pH is bouncing all over the place because there's not enough alkalinity to control pH and to provide the proper buffering. Right size umbrella with right size pH, you're good to go. It's golden. They work together hand in hand. I call pH a little puppy that follows alkalinity around all the time, and that's a good way to think about it. And with alkalinity, remember alkalinity is not, there's not just one thing called alkalinity. It's comprised of a lot of little things: bicarbonates, carbonates, hydroxides, cyanurates, borates, sulfate, a couple other minor things. But it's comprised of a lot of little things. And why am I telling you this? Well, with alkalinity testing, if you do a total alkalinity test and you know there's cyanuric acid in your sample, that alkalinity answer you get is wrong because it's reading also the amount of cyanuric acid in the sample. So what do you do to correct it? You take 1/3 of the cyanuric acid reading and subtract it from your measured total alkalinity reading. The resulting number is what we call carbonate alkalinity, or some people call it true alkalinity. So let's do an example. The pool we were at this afternoon, okay? We figured it was about, let's say it's 150 parts per million cyanuric acid. 1/3 of that is 50, right? We did the alkalinity test, and the alkalinity test, if I remember right, was 80 parts per million. I think that was it.
I think so.
Okay. Subtract 50 from that.
Right.
30 parts per million is what the true carbonate alkalinity reading is. And is that a good number? Heck no.
Right.
80 to 120 is the ideal range. Okay? So what that test is reading, it's reading that cyanuric acid value also and giving you a false number, thinking you're fine when you're really not. Okay? The other thing, too, is that we found that borates have, and that's becoming a real popular product nowadays. I don't know if you guys are familiar with it out here, but borates help control pH a little bit better. It makes the water feel better on your skin, that kind of thing. It's 20-multine borax. I don't know if you ever heard of that before. I'm reaching back into the black and white days of TV. But you add a little bit of borax to the water, and it creates that effect. Well, what we're finding out is that there's a slight effect of borate presence, which is what's created in an alkalinity test. So you have to correct your carbonate alkalinity reading, even more so if you're using a borate product. But it's very, very minor. We have a chart in the back of our booklet that helps you do that. It's not a biggie, but it's enough that you really kind of need to be aware of it. Okay, particularly if you're using test strips where you don't have that ability to test or correct things as easy as you would with a regular test kit. But getting back to alkalinity, standard test, it's a drop test. You go from green to red. You count the number of drops it takes to do that. You're good to go. What screws up a total alkalinity test? How low high chlorine and bromine. Same thing. High chlorine and bromine seem to be the bad boys of a lot of these tests. But what happens normally is that instead of going green to red, it goes blue to yellow. Urine kind of yellow color that you normally don't want to see in pools, but that's what happens. And that's a clear sign that you have a high sanitizer reading. And the easy way to correct that, again, it's in our booklet too, under the most commonly asked tech questions, is that you get a new sample, and instead of adding 2 drops of number 7 like the normal instructions say, you double it to 4. In this case, adding more thiosulfate, you're not messing up your sample. It's still good. And then you do the test normally, you get that right green to red color change. So a lot of times I'll get, my alkalinity test came out blue. Oh, okay, here's what happens. Then you tell them how to correct it. Another thing that can mess up a total alkalinity test is if the indicator is old. And you can tell that by looking at the bottle and checking the expiration date, or if you don't have one, you get some really weird colors. You get this red and green kind of swirly it's really not pretty at all. It's more like, what kind of thing. But the one other thing that affects a total alkalinity test, and we were talking about this earlier, is PHMB, polyhexamethylene biguanide, otherwise known as Baquasil kind of products, the non-chlorine bromine product that people use when they say, I'm allergic to chlorine or bromine, that kind of thing. What that causes is a color change. Instead of going green to red, it goes blue to yellow. But in this case, believe it or not, that's a good color change in the presence of PHMB. So if you have customers that are using the Baquasil kind of products and they get that color change for an alkalinity test, it's not an interference. Well, it is in the sense that you're changing the colors, but the value is still perfectly fine.
What exactly is the Baquasil products?
Baquasil. Baquasil is something called PHMB. It's the brand name for PHMB, polyhexamethylene biguanide. It's I won't say a substitute for chlorine or bromine, but for people who say that, I'm allergic to chlorine and bromine, I can't have any in my swimming pool, what do I do? This is the product that they would use. It's a microbiological control agent. In other words, it kills critters, okay? But it doesn't oxidize. So you have to add hydrogen peroxide as an oxidizer to it to have that oxidizing effect. And the bad thing about the product is that it's completely incompatible with pretty much everything else that you would think about putting in water. Algicides, and any other kind of treatment, shock, chlorine, bromine. If you add chlorine or bromine to a PHMB pool, it looks like snot. Basically, it really mucks it up. And after about 2 or 3 years, of being on this, people tend to get very lazy and will throw chlorine in there, forgetting that they have Baquasil in the water, and their pool gets all messed up. It's not a good situation.
Yeah, I don't think we deal with that very much.
Yeah, you don't see that too much out here in this neck of the woods. It's popular in Florida and in parts of California, but it's been around for a long time.
I can see California dealing with that.
Yeah, well, it's California. Sorry, guys.
Nice.
I have a lot of friends out there. Sorry, California.
So do we.
So how would you adjust the alkalinity?
Same way you would with pH. You add acid to lower it, whether it's muriatic acid or sodium bisulfite triacid, doesn't matter. And to raise it, you would use bicarb, good old Arm & Hammer baking soda.
And is that assuming that the pH and alkalinity are both high, or vice versa?
Well, yeah.
What if one or the other is off?
Yeah, you can get situations in which you have like a very high pH and a low alkalinity, or vice versa. What do? Well, you're kind of stuck between a rock and a hard place. There are methods that are out there. Some people agree with them. Some people don't. I tend to agree with them. If you've ever heard of the term slugging acid or broadcasting acid, if you have a high alkalinity situation and a low pH, okay, you need to add acid to lower the alkalinity, but you also know that by doing that, pH might bottom out. What do? Well, you would do something called slugging acid. And what slugging acid is not pulling back and getting ready to hit it. It's you pour the acid in like you would a Drano or liquid plumber into a clogged drain in columns, mostly in the deep end, away from return lines. Keep the pumps and filters off in this case. And the process of putting it in that columnar action actually reduces alkalinity more than it would pH. It will lower pH slightly, but not dramatically. Now, if you had the opposite situation, where you had a high pH and a low alkalinity and you needed to lower pH, you would do something called broadcasting acid, and it's not throwing it across the surface. You would take it and pour it you would pour it around the edge, like you'd walk it around. That creates like a waterfall effect going into the water, and that actually lowers pH more than it does alkalinity. It will lower alkalinity too a little bit. That's why it's important that I mentioned earlier, you always retest the other parameter after you've treated one to make sure you're still within the right range.
And I know that's not super common, but do you have any idea why they kind of wouldn't? Because, I mean, for the most part, if the pH is high, the alkalinity is right behind it.
Yeah, usually. Yeah. A lot of reasons. Could be source water. It could be a certain treatment chemical had a weird pH, for example, it caused it to change. It could be in people, things get in the water. It could be a lot of reasons. Like you said, it's not common, but it's there. It's out there.
The unknown is pretty crazy. I mean, just to think, if there was a pool person cleaning my pool, I was in the pool yesterday with my girls, and there was just a matter of being in there. Soda dumped in the pool, half piece of ice cream went into the pool. Like, you know what I mean? There's just many things that like we can clean up, and the pool guy comes in like, what the hell?
And you don't want to know what's in hot tubs and spas.
I wasn't going to talk about the
we
other
don't go
stuff.
there. No.
Yeah, no.
Yeah.
Nope.
So, but no, you're right. And everything you add to the pool might have an effect on it. It's just that as long as it's not a whole lot of bad something, it's not going to be a terrible issue. Like, an ice cream cone falling in the water. Yeah, sure, sloppy, but
Can I still eat it? Hell yeah.
yeah. It's ice cream. Yeah, of course you're going to eat it. Yeah.
So when you treat pH, you use soda ash. That also brings up alkalinity, right?
A little bit, yes.
Yeah. So with bicarb, people say it doesn't bring up pH. Is that
It does a little bit, but it also depends on how much you're adding. If you're adding a lot of it, yeah, it'll bring it up. But if you're adding, like a pound or a half a pound of something, no, it's not going to bring it up.
okay? No. So why do you choose bicarb over soda ash?
Because bicarb has a greater increasing effect on alkalinity than does soda ash, and soda ash has better increasing effect on pH than bicarb.
Okay.
Yeah. If you got that, remember it. You'll be tested later. Yeah.
Is there anything that people should be, I don't know about concerned about, but should know about DE? Is there anything in DE for just the DE filters that kind of can affect the chemistry at all?
No, not really, but you want to be careful, like recharging a DE filter, adding more DE. You don't want to breathe it in. That's why you wear a mask. You better be wearing a mask because the product itself can get into your lungs and actually solidify your lungs. It's kind of like pneumonia, but it stays there. It doesn't go out. It's really kind of dangerous. But wearing a mask. But the actual DE process itself, no, it doesn't cause any kind of chemical changes.
I don't think I've ever seen anybody wear a mask pouring DE through the skimmer.
I do this.
Yeah, if there's anything that you want to wear a mask for, it's dealing with DE.
Yeah. And it's
So
so
we just rip them out like we do. So
it's so fine, it's sneaky, dude. It'll get through that shirt somehow and that beard.
just get them out. Just take them all out of it. I don't deal with DE filters anymore.
I wear my Scream mask. You ever see my Scream mask? I wear that when I pour it. Neighbors or the homeowners don't like it, but gets the job done.
Yeah.
I'm safe. All right. So
Anything
I
more
think,
about total alkalinity? Okay.
A lot of good information on both those.
Okay.
Thank you guys so much for listening. We truly appreciate you giving us your time and your ear. We know how important and valuable that is. So thank you for joining us today. If you have any questions, you can reach us at poolchasers.info@gmail.com. Follow us on Facebook, Instagram, and Twitter. Our tag is Pool Chasers. If you guys could take a minute and go to Apple Podcasts to rate and review the podcast, we would truly appreciate it.
See you out there, Pool Chasers.